Okay, here's where you'll see the notes here that now we're going to tie in and use pretty much all this that we're looking at. Polynomials, we're looking at equations in quadratic form. Remember, quadratic equations are to the power of 2, but they're not initially going to look like they're quadratic equations, but you're going to treat them that way, and you're going to see how they're actually going to be very, very similar. Not all of them are like this, but at least know these here. Okay. We're just going to do the factoring part. I'll do the solving and everything else in the third video here. So here we go. Let's see. Number 1. So we're just going to factor, right? If I give you a quadratic, let's say x squared plus 7x plus 10. Okay, and you're going to factor this. Well, this one's factorable. That's the good thing. The ones you're going to see, they're all factorable. This would be x plus 5 and x plus 2, yes? Right, and over here, I'm going to kind of make 2 columns here. Sorry for the pause. I'm going to make 2 columns. This column here is going to be quadratic, right? Because it's to the power of 2. So this will be like 1a. And this one's going to be 1b. And you'll quickly realize why it's not like 1 and 2. It's 1a and 1b. Well, if I can solve it as a quadratic, these are the new ones. This is a quadratic. This is a polynomial. I mean, honestly, they're all going to be to the power of 4, so they're called quartic. They're not called quadratic. They're called quartic. But this will be the new ones here in pre-calculus. These will be the new ones here on this side. And again, anytime it's anything higher than, well, anything, even if it's to the power of 2, to the power of 3, and now we're seeing to the power of 4. They just call them all polynomials, right? But these are the new ones. If you can do this, you can do this. x4 plus 7x squared plus 10. Does everybody see how I pretty much have the same thing going on here? I mean, yeah, the power is different. This is to the power of 2, and this is to the power of 4. The ones you learned last time were to the power of 3, but then, you know, there was a common variable you can factor out. Always look for that. Always look for a variable, but this one doesn't have a common variable or a common factor like a common number. It doesn't have it. I can't factor anything out. But what I want you to just look at is, look at this. This one has a plus 10. This one has a plus 10. This one has a 7. This one has a 7. And then, well, this one has x squared, but this one has x4. But essentially, it's the same problem. It's a 7 with a 10. It's a 7 with a 10. And see, so now, the only thing is that you notice that the degree has been doubled. Or squared, let's say it. It's been squared. This is to the 2, and 2 squared is what? 4. And this is x, and x squared is what? Well, x squared. So my point being is, if I'm starting with this one, I would actually go back and write this one first. I would go back and say, hey, this just looks different to me. It just doesn't look right. I know I'm used to seeing this. I would write it in this form first, factor it. And once I know how it factors, now I can come back, right? I write it like this as a quadratic because this is what you're familiar with, right? This is what you should be strong with quadratics. Once I can get it factored in a quadratic form, I can come and do this one. These two are actually the same problem. The only difference is the degrees are higher. You see, the degrees are higher. So if to get x squared, it's x, to get x squared is x times x, right? You don't put x squared here and you don't put x squared here, right? X times x is x squared. Well, what do I have to put here? Here's where you are going to put x. You can't put x and x. This is where you're going to put x squared. But the plus 5 and the plus 2 stay the same. You see it? And notice that the middle term, which is x here, is one single x. And notice that the middle term here is x squared. Well, it's x squared here. So that's how I want you to look at it. They're equations in quadratic form, right? It's only the degree that's different. Okay? So let me do one again, going forward this way. One more like this, where I start with the quadratic and then I go this way. But honestly, then we'll start with this one. Let's do another one, 2a. What if I give you x squared, or what if x squared minus 3x, what should I go here? Minus 28, sure. How would you factor this? Over here, it'll be what? It'll be the same. It'll just be, this will go from 2 to 4, and this will go from 1 to 2. This will be squared. So it'll be x4 minus 3x squared. See, it kind of goes in evens. Minus 28. You guys see how the negative 28 is still the negative 28, and the negative 3 is negative 3? Okay, so how would I do this one? We'll get to this one here. Well, 7 times 4, right? X. I need x times x to give me x squared. And this will be a negative 7 and a positive 4. So now that you see this one, well, to get the negative 28 and the negative 3, see, this is still the same, the minus 7 and the plus 4. But now this is going to be what? X squared, right? X squared times x squared is x4. You guys see it? So this is 2a, this is 2b. All right. So now let's start it just from here. This is how I want you to look at it. This is how I want you to think about it. When you get a problem, let me start with 3b. And then I'll write it over here as 3a, right? When you get a problem, it's not going to be written like this. It's going to be written like this. It'll be x to the 4 plus 2x minus 24 is fine. Oh, I'm sorry. That'll x4, that'll be x squared. Sorry about that. When you have this problem, I don't want you to do this problem. I want you to do on the side somewhere, I want you to look at this as a quadratic. Why do you think this is called equations in quadratic form? Right? Don't try to learn something new. Just take it to something that you already know how to do, and then work it out that way. So if I have this problem, I'm going to rewrite this one as a quadratic. This one, if it's quadratic, it would be x squared plus 2x minus 24. I know some of you can see it already. I know some of you are going to be good like that. But I'm just telling you, it's going to help, because these numbers throw you off, right? Especially the degree. Looks intimidating. You're not used to seeing this. You're used to seeing this. Okay, now you come over here and you say, okay, how would I do that? That would be x, because x times x is x squared. And this, the numbers that are going to work here are 6 and 4. 6 times 4 is 24. And 6 times 4 can give you a 2. So that'll be a positive 6 and a negative 4. And once I know how to factor it as a quadratic, I can come over here now and do what? And now write the answer here for this one. It's going to be plus 6 and it's going to be minus 4. But instead of x and x, it's going to be what? X squared, x squared. Does that make sense? I know some of you might not want to go do this back and forth business, but I hope you see why they say that these, even though they're not quadratic, right, it's to the power of 4, they kind of really are in this quadratic form, right? Okay, let's do one more. 4b, and this will be 4a. So again, the problem is not going to be presented as a quadratic. It's going to be a polynomial, and in this case they're all going to be to the power of 4. X to the power of 4. Let's go with minus 8x minus 20 up 8x squared minus 20. Okay, well, that's to the power of 4. I don't know that one. So I'm going to write it first as a quadratic, which would be what? X squared minus 8x minus 20. I'm going to factor it and think. See, because I'm thinking in quadratic. I'm thinking this. This is what I'm sharp at. This is what I'm good at. So that would be xx. And that would be a 10 and a 2, right? 10 and 2. Is that good? 10 and 2, right? 10 and 2 can multiply to 20, and 10 and 2 can subtract to an 8. And that would be a negative on the 10 and a positive on the 2. Yeah. Yeah. Okay, so if this is the way it factors for this, then now you know, now I get this, and now I know how it factors for this one. It's still going to be minus 10, and it's still going to be plus 2. But here is going to be what? X squared and x squared, right? Because x squared and x squared gives me x4. All right, hopefully this is easy. Not too much new stuff. It's ties into something that you already know. And hopefully now you see why they call these polynomials or equations. They're not quadratics. These are not quadratics, but they are in quadratic form. All right. This lesson combined with the previous video with the square root with the negative is, now we're going to use all of this on the third video, which is coming up next. So watch that one.